So very good morning to all. Myself Venkat Suppura Vemalapati, so Assistant Professor in the Department of Electrical and Electronics Engineering, SESI Institute of Technology and Engineering. Today we are going to discuss about the topics under power system protection. The topics to be covered in this session. So why we need the protective systems for the power system, and what are the nature and causes of faults. So whenever we are talking about the protection, so there is a faults in the system. So from the faults we need to protect the system. So what are the nature and causes of the faults, and what are the different types of faults, and what is the effect of faults. So the effect may be in the sense of loss of damage, severe hazards, fire hazards. So there are many effects of faults are there. So we will discuss today. And the next topic is zones of protection, and the primary and backup protection, and finally we will conclude with the essential qualities of protection. So these are the topics to be covered in this session. So the first topic, why we need for protective system. So we need to protect the power system because the power system includes many stages. The total power system includes the generation part, transmission part, the next one is distribution, and finally the utilization. So transmission, power generation, transmission, distribution and utilization. So in these stages of power system, we are using many equipments which are dealing with high voltages, medium voltages and low voltages. Sometimes we are going to dealing with 700 kV, sometimes 400 kV, 11 kV, 66 kV, 32 kV, 132 kV. So these are different voltage levels we are dealing in the power system. That's why we need to protect the equipments, as well as we need to protect our system or equipments from the faults. So short circuit and abnormal conditions often occur on the power system. Then the word short circuit itself indicates creating a low resistance path. The short circuit means it is having a very low resistance path, and abnormal conditions we can take in abnormal conditions in the sense of cyclones, or whenever the tree falls on the transmission lines. So these are the abnormal conditions. So there are some faults will be occur, and that will be damage to the power system. So those are short circuit and abnormal conditions. We need to protect our power system from that short circuit and abnormal conditions. Heavy currents associated with the short circuits. So whenever the short circuit occurs, the low resistance path will be created, and that low resistance path will make the voltage zero, and the heavy inrush currents will be generated. Heavy currents will be associated with the short circuit current, short circuit faults. And finally we need to protect equipment. The equipment like transformers, generators, transmission lines, feeders and short circuit, these are all the heavy, costlier or important equipment in the power system. We need to protect all those equipments. The fault may be occur anytime. Today fault occurs, we cleared it, and tomorrow maybe there is an unnatural fault because of abnormal conditions. So we need to protect at any time, every time, always. So that's why this equipment protection is required. The most equipments are transformer, generator, transmission lines, and we need to protect from damages due to overcurrent and over voltage. So if the voltage is crossing the limits, then the equipment suitable or equipments designed for certain voltage is incapable of handling that voltage. So in that situations, the equipments may be damaged. In the same way, overcurrent and over voltage, overcurrent, under voltage and low current also. So these faults can arise from various causes, including lightning strikes, lightning effect and breakdown of equipment failure. So there are many causes for these faults, and we need to maintain the reliability in the system. So the equipments are designed to do particular thing or particular work. If these faults occur, the designed work may not be possible, or required things may not be arises. So that's why the reliability will changes. So we need to maintain high reliability in the devices or high reliability in the power system. That's why we need to make system reliability. So these are the reasons to maintain the protective system or required need for protective system in the power system. And prevent damages and losses, heavy short circuit current, maintaining power quality. So this power quality is a heavy subject, and we are losing the power quality, the quality of power in the sense of under voltage, low. If it is a voltage is at standard level, frequency is standard level, current is standard level, then it is a quality of power. If the voltage deviates, frequency deviates or current deviates, that is under abnormal condition that will lead to the power quality issues. We need to maintain the power quality. So maintain power quality, and overall protective system plays a crucial role in ensuring the safety, reliability and efficiency of power system. We need to maintain the reliability, safety and efficiency of the power system, thereby benefiting both utilities and consumers. So ultimately the power is utilized by industries or the normal consumer or industrial consumers. So we need to maintain the beneficiary. So those are the ultimate beneficiaries. We need to make reliable system. And the next topic we need to discuss about this nature and causes of faults. What is the nature of fault and what are the causes for the fault? Coming to the nature, short circuit faults. Short circuit faults. Short circuit faults occur when low resistance path is created between two or more conductors, leading to a rapid flow of current. Mainly these short circuit faults occurs mainly due to the insulation failure. So in the power system, when you are making transmission lines or creating power flow, we are using some insulators for safety purpose. If the insulation failure occurs, the short circuit may be possible. And finally, lightning and switching surges. Lightning is a normal phenomenon when a cyclone or heavy rains occurs in the natural thing in the monsoon season. And in that situations, there is heavy possibility of short circuit faults. And finally, the next one is the open circuit faults involve break or discontinuity in the conductor. Whenever the conductor breaks, the breaking may be possible. I can give you one example. If the tension in the wire, if the wire is tightly bounded or any wind flows, heavy wind flows, then the tension in the conductor may be heavy and large, and that tension may create the breaking the conductor. So that involve break or discontinuity in the conductor, resulting in interruption of the current flow. That is open circuit. So the conductor is open circuited, that is not connected in the system, that is open. And the next may be ground faults. The conductor break down and falls on the ground. A ground is a good conductor. The current is continuous but into the ground. In open circuit faults, the conductor breaks down, but that is isolated, no current flow into the circuit. But in the ground faults, in the ground faults, the current is not zero. But in open circuit faults, the current interruption of the current is equal to zero. I will become zero in the open circuit faults. And finally, faults may be transient or permanent. So whenever the fault occurs, whether it is short circuit fault or open circuit fault, it may be transient. Transient means within seconds or within milliseconds, the system will relocate or rearranging itself. Or the next one is, it is permanent. So the permanent means the fault is not cleared within short time and it leads to the damage of the system or damage of the equipment. So that is, faults may be transient or permanent. That is the condition. So understanding the nature and causes of fault helps implementing the preventive measures. So when you are understanding nature and causes of faults, it will helps in implementing preventive measures. What are the preventive measures we can maintain while these faults occurs? So this is the nature of the fault. Next we will discuss about types of faults. So here there are nearly two types of faults in the power system network. The first one is symmetrical faults and the next one is unsymmetrical faults. So these faults occur when all three phases are involved equally. For instance, in a three-phase fault, the fault currents in each phase are symmetrical or balanced. Symmetrical faults are electrical faults that affects all phases of the power system equally. They occur when all three phases experience the same fault conditions simultaneously. So for example, if you take so three-phase faults. So if it is a three phases, it's a three transmission line. When the three phases are short circuited, then it is a symmetrical fault. You say three phases faults are symmetrical faults. The three phases may be short circuited, or these three phases are short circuited and faults on the ground. So these faults comes under symmetrical faults. The next one is unsymmetrical faults. When the faults occur in a power system are not balanced. So if the three phases are available, if three phases are short circuited or three phases are short circuited and faults on the ground, that may be represented as triple L fault or triple line to ground fault. When three phases are short circuited and three phases are short circuited and faults on the ground. So triple L and triple LG faults. These are all come under symmetrical faults. Come to the unsymmetrical faults. When the faults occur, when the fault currents in a power system are not balanced. Suppose in three-phase system, one phase is having an issue, remaining two phases. What does it mean? Two phases are a healthy condition, one phase is having a problem. Then the balance will be missed on the faulty condition or faulty phase. That's why the current flowing in the faulty phase may have zero or heavy current. If it is an open circuit, zero, or if it is a short circuit, heavy current will flow in the faulty phase. So that's the condition that is not balanced or symmetrical across the phases. It's a not balanced or not equal or unsymmetrical currents flow in the phases. So the faults may be, if it is same again, three lines, there are many options here, unsymmetrical faults, or there are many chances are available. Only this phase will falls on the ground. Suppose this may be R, Y, B phase. Only this phase may be falls on the ground. This is line to ground faults, and it is line to ground fault. This is the faulty section. These two are healthy, and the current in this section, when it is falls on the ground, heavy current will flow in this phase. So the current is unbalanced and unsymmetrical. And the next one is and the next type of fault, we can assume these two lines may be short circuited. This line and this line. This is line to line fault. Line to line fault, and this phase may be healthy. That means the currents in these two phases are unsymmetrical or unequal. And the next chances may be line to line fault, and these are all falling on the ground, line to line ground. Line to line ground fault. So these are different unsymmetrical faults are available, or sorry, unsymmetrical faults may be causes in the power system. So we'll discuss all those things in the continuation part. Types of faults and short circuit fault, open circuit faults, and phase to phase faults. So these are all different types of faults. Phase to ground faults, three phase fault, symmetrical and unsymmetrical. So these are the things we discuss right now. So coming to three phase faults, that is triple L to triple L fault and triple L to ground fault. Unsymmetrical fault, line to line, line to ground, double line to ground. So these are the unsymmetrical faults. Now we will discuss about the statistics of the occurrence of the faults. The probability of faults occurrence, if you see, where the major faults occur in some of the equipments, and so if you consider overhead transmission line, underground cable, current transformers and potential transformers, power transformers and miscellaneous things, the occurrence of faults, the 50% of faults only occur on the overhead transmission line. That means half of the faults or majority of the faults occur on the overhead transmission line. Underground it is 10%. The mostly the switchgear, current transformers and potential transformers, these are used in the switchgear or protective devices. So the faults occur in these CTs and PDs will be 15%, and power transformer available in the substations or wherever we are stepping up the voltage or stepping down the voltage, we are using these power transformers mostly in the substations or power grid. So these power transformers will face a 15% of faults. So this is the probability of occurrence of the faults in the different equipments in the power system. Under overhead transmission line, what are the different types of faults we already discussed? Line to ground fault, line to line fault, double line to ground fault and symmetrical faults. So these three are unsymmetrical faults. This is symmetrical fault, triple line and triple line to ground faults. Under transmission line, the major fault or the major fault occur in the transmission line is LG fault. The probability is 80 to 90%. That means out of 100, 80 to 90 faults, 90 types of 90 faults only under LG faults. So the occurrence of probability is 90%. More problems or more occurrence of fault is LG. And double line fault is 6 to 10%, double line to ground fault is 3 to 6%. And finally the symmetrical faults, triple line and double line to ground is 1% or less than 1%. So from this we can conclude that line to ground fault is the more occurrence of fault, but symmetrical faults, triple line and triple line to ground fault is very less occurrence of faults. And here now we will discuss about effects of faults. These are the faults occurrence of the transmission line or power system. What are the effects? As we discussed earlier, the heavy short circuit current. Heavy short circuit current will be developed in the system because of short circuit. Arcs associated with the short circuit. So the arcs means whenever the short circuit occur or the failures of the system, the sparks between the two elements The arcs associated with short circuit may be cause fire hazards. So we mostly see these fire hazards in the industries or sometimes in the homes. So fire hazards due to short circuit problem. So that is the only cause for the fire hazards is the arcing effects. The arc or the sparks may be generated by use of by short circuits. That will cause fire hazards. And there may be reduction in the supply voltage of healthy feeders. Because of this short circuit or open circuit, the voltage in the system in the healthy feeders will be reduced. Why? Because there is a creating unbalance in the system. That's why the healthy feeders will affect a low voltage or experience a low voltage, resulting loss of industrial loads. If the voltage is reduced, the industry loads will be disconnected. And short circuit may cause unbalance of supply voltage currents, thereby heating rotating machines. So in the industry, 90% or 90 or 80% of motors are induction motors. If the unbalancing the voltage and currents, it will heating the machines. So that the damage will be occur in the industry part also. So that is heating rotating machines, whether it is induction motors or synchronous machines, anything. And there may be loss of system stability. So whenever the voltage is unbalanced, automatically the system will unstable, and there is a cause for instability and collapse of the system. All these faults causes interruption of power supply to the consumers and consumers like us, and thereby causing loss of revenue. If the government or the power supply units unable to supply the power to the consumer will never use. If consumers are not using the power, automatically the revenues for the government will automatically reduces. So that is the meaning for cause of loss of revenue. And high grade, so these are the effects of faults. To overcome these effects of faults, we need some high grade, high speed, reliable protective devices are essential requirement in the power system. To overcome all these effects or to overcome all these faults, we require high grade, high speed and high reliable protective devices. The next one, we need to protect. As we discussed earlier, the power system is not only subject to one particular thing. It contains generation part, transmission part, distribution and utilization part. So there are different zones are created to protect a different equipments. So here we discuss about the zones of protection. So the protection zone, the definition we can see, the part of the power system protective zone is nothing but it's a part of the power system which is protected by a certain protective scheme. It is established around each power system equipment. When the fault occurs on any of the protective zone, then only the circuit breakers within that zone will be opened. So the power system is divided into particular zones. Each zone is provided with the circuit breakers, relays and everything. If any fault occurs in that particular zone or that faulty zone, the circuit breakers corresponding to that zone will be operated and that section will be isolated from the healthy zones. So that we cannot disturb all the network. So we can isolate only the faulted zone. So those are the meaning for creation of zones of protection. So here, if you see, first we have a generation part. So the power may be generated at the power plants very far away from the consumers. So that is generator. We need to protect that equipment, generator. For that, so this zone will be created. So this circuit breaker will be used or operated whenever the faults occur on the generator. So that is generation side. If any faults occur, this circuit breaker will be operated. Then that will be one zone. And the next one is station bus bars. So after generation of power, it will be connected to a bus bar, and this bus bar will be connected, and this bar will be attached with the circuit breakers, and the next one is we use transformer to step up the voltage. So here I can write, suppose the voltage generated may be 11 kV or 22 kV. So this bus bar may be 11 kV or 22 kV. So here the generation voltage may be 11 kV or 22 kV. This will be connected to this bus bar, and this bus bar is attached to the circuit breaker, and then it is step up the transformer, the step up the voltage with the step up transformer, that may be 400 kV. From 11 kV to 400 kV it will be step up, and this zone is overlapped between this generator protection and this circuit breaker and bus bar protection. So LV switchgear protection at station bus bars. So this protection, this zone and this zone are overlap. This may be possible in the power system protection. Okay, the next one we are going high voltage switching protection. Why? Because it's a 400 voltage. So this circuit breakers is operated at 400 voltage kV. This circuit breaker may be operated at 11 kV or 22 kV, but this circuit breaker has to operate at 400 kV. So the suitability of circuit breakers also we will discuss in the further classes. So these are the very important topics. So at the end of this session I will give some assignment questions, and I will provide the link for uploading of your assignments, Google form, so that we can answer all these questions. So these are zones of protection, the causes of faults, what is the reason, and types of faults. So these are the assignment questions I will provide at the end of the session, and you can submit through the Google form. Right? Okay. So this high voltage switchgear protection at sending end, and finally, and again at the end, again we step down transmission, again step down to distribution and distribution. So these are the different power system causes, and at each stage we are using these protective devices, and the division of zones from generator to bus bar, so overlapping is possible, and from this bus bar to transformer there is overlapping is there. High voltage switching air protection. So each station or each system is divided into zones. The system contains generators, transformers, bus bars, transmission and distribution lines. Protective scheme is each piece of equipment divided into zones, so that we are divided into zones of each and every equipment, and zones are planned such that no part of the system is left unprotected. So we need to create zones such that no part of the equipment is should not be left unprotected. We need to protect each and every equipment in the system. So we need to plan such that we need to create a protection such that it has to be no part of the system is left unprotected, and adjacent protective zones must be overlap each other. As I mentioned earlier, generator protection and bus bar protection, those two zones are overlap. It must be, it's unavoidable. Okay, right. So this is regarding zones of protection. And the next one, primary and backup protection. So here the protection schemes divided into primary backup and secondary backup, or in general we can say plan A or plan B. If plan A fails, we will go for plan B. Similarly, there is first line of defense. Similarly, we have first line of defense and second line of defense. So primary protection and secondary protection. If the primary protection fails, irrespective of the fault, irrespective of the damage, the secondary will operate. That is the meaning that is second line of defense. Reliability of protection scheme should be at least 95%. So if any faults occur, the system has to be protected by using protective scheme, the reliability of that protective scheme should be, or probability should be 95%. Or if it's at least, it should be 99, or if possibility is 100%, but at least it has to be 95%. Achieved through proper design. How can we achieve 95% or 99%? It can be achieved proper design of circuit breakers. How can we design the circuit breaker? It has to be based on the voltage level, or it has to be based on the frequency, it has to be based on the occurrences of faults. So there are many factors for choosing of circuit breakers or designing purpose. So there are many factors affecting. So the design is very important thing. And installation and maintenance of the relays. How relay works, how circuit breakers will work. So we will discuss all those things in the further classes. So the relay will give the signal to the circuit breaker to operate, and the operation will be discussed in the next class or further classes. But we need to maintain those circuit breakers. The regular maintenance is causing 95%. Reliability maybe increases. And circuit breakers, backup relays are made independent of those factors which might cause primary relays to fail. And large part of the power system is disconnected from the power source, but this is unavoidable. So coming to the backup protection, if the primary protection fails, that means within short time the circuit breaker is not operated, or within transient fault is not transient. In that case, the primary protection may be failed. Irrespective of independent of those factors, the second relay will be operated. Whether it is a high system or high voltage system or whatever it is, the secondary protection will operate, and the large part of the system will be isolated. What is the result for that? We need to restore the system. It will take time. If the secondary protection or backup protection operates, means large part of the power system will be isolated, but reconnecting it will take time. If it is a primary protection will operates, it is easy to restore the system. But how will the secondary protection will works? Irrespective of the problem, irrespective of the dangerousness of the problem or level of the fault, the system will be isolated by the backup protection. And backup relays, remote backup, relay backup, and breaker backup. So each and every protected system there is a backup system. So this is the primary and backup systems. And finally we will come across these essential qualities of protection. So we are designed system, circuit breakers, we are implemented, we are protected zones. So each zone we are having circuit breakers, relays, everything. But what are the objectives, or what is the essential things required by the circuit breakers? So essential qualities of protection. So selectivity or discrimination. Sorry. Selectivity or discrimination. So we need to select a proper circuit breaker for the proper operation. We cannot use a circuit breaker which is suitable for 33 kV, we cannot use the same circuit breaker for 400 kV. So the selectivity or discrimination, differentiation is very important thing. So that is the first of important selectivity. And that circuit breaker also has to select or sense the proper things, or it has to operate quickly. And reliability. Reliability means whenever the fault occurs, the circuit breaker has to be open. That is a required thing. If 100 faults occur, if it is 99 times it is operated, that is 99% reliable. So as we discussed previously, the reliability has to be at least 95%. And the next one is sensitivity. Yes, if the relay is there, it has to sense any over voltage, under frequency, over current, any faults, a lightning strike. So anything has to be sensed by the relays. The relay is designed to sense. That is designed for protective, for sensing. any faults occur, it has to be sense the fault. So that is sensitivity and stability. Whenever the fault occurs, first of all, the circuit breaker or relays has to be stable. If those are damaged earlier, who can protect the other system? So that stability is also important. Finally, fast operation. It has to be quick operation. Whenever the fault occurs, immediately the circuit breaker has to be operated. Even if some few seconds are left, then the system may be damaged. So the time settings, so everything will be discussed in the further classes. How much time it has to be operated, how can time settings will be there, the relay time, how it will sense the signals, and how it will send the signal to the circuit breakers. All these things will be discussed in the further classes. So these are all essential qualities. And finally, so these are the assignment questions I am providing. So these questions and link will be provided to your WhatsApp groups, and so that you can answer all those things. Thank you.